All right, just like with the prisms, cylinders are like slinkies, but this one they use a stack of CDs. It doesn't matter if you slant it or if it's straight up and down. It's going to have the same volume because of Cavallari's principle. Now, really, cylinders are the same. The formula is the same. It really is area of the base times the height. But what's the base of a cylinder always? A circle. So I can put in pi r squared times the height. So my volume, I just plug it in. And we should be able then to solve for the height of my cylinder. Now here I have an oblique cylinder, and the diameter is 18. Well, I end up getting the fact my radius is 9. So all I do is write down my formula, pi r squared times the height. I go pi times the radius times the height. I get 81 times 14, and I get 1,134 pi cubic inches. Notice this is really fast process with cylinders. It's very simple to do. Then on this next one, it says find the volume of a right cylinder that has a diameter of 16 inches. Well, that means my radius is 8 inches and a height of 17. So when we do this, our formula is pi r squared times the height. And it says leave your answers in terms of pi. We have no other way I'm going to do this unless the book tells you otherwise. And then you use your pi key. We get pi times 8 square inches times the height of 17. And I get 1,088 pi cubic inches. Volume is very straightforward on cylinders. But now I'm going to do kind of a combo package here for you, and I'm going to make sure that I can work with this. These are those work backwards problems. If I give you either lateral area or surface area or volume, I'll guarantee you're going to have to work backwards to solve for something missing. Notice what this one's doing here. It says find the height of each figure with the given volume. I'm looking for the height for each one. Now notice though they gave us the volume. So I know what my volume is, and I even know my volume formula. My volume formula is area of the base times the height. Well, that means I have to know what the base is. Well, here again, because it's the two parallel sides, this triangle is my base. And to save time, I shouldn't have to draw it, but you know what? I want you to stay in that habit. So this is 3 and this is 5 inches. You don't have to do the perimeter, but you do have to find the area of the base. Oops. Yeah, it is. Oh, I'm totally second-guessing myself. I was thinking ahead on the next problem, and I was going, oh, circumference, sorry. Base times height over 2. Well, remember the legs of a right triangle acts as your base and your height. So that's 15 over 2. Now I can plug in what I know. I know I have 45 cubic inches is my volume. The area of my base is 15 over 2 times the height. Now, if it helps you, rewrite it like this. Okay? Now, go ahead and multiply both sides by 2. Because it helps me get rid of the 2 on this side. So I multiply both sides by 2. And then divide both sides by 15. My height ends up being 6 inches. Now I'm going to do the same type of process for a cylinder. I know the formula is pi r squared times the height. I gave you the volume, so I get 20 pi. I know my radius, that's 2 squared, times the height, so I get 20 pi equals, what's 2 squared? 4, so I get 4 pi, my equal sign a little bit better there, times the height, and then I got to get height by itself. So I divide both sides by 4 pi. Well, the pi's simplify out to be a 1, the 4 simplify out to be a 1, and I get 20 divided by 4 here, which is 5. So that's 5 meters is your height. And you're going to have to do that a couple times on this lesson. So hopefully this will help you get started when you're working with the volume of prisms and cylinders.